Hey everyone, this is a quick recording of the Cryptarithm question we were meant to discuss in class today. I actually did a recording before, but it turns out I wasn't recording audio, so I'm going to rerun through it here again. So what we have here is this Cryptarithm with idea plus idea is learn. So our goal is to make the value of learn as big as possible. So we're trying to maximize the value of this bottom number, learn. All this means is that, by the way, what this means is that like idea plus idea is learn, is this is a 4-digit number plus a 4-digit number equals a 5-digit number, and each letter it represents a digit. And another rule is that we're not allowed to repeat digits, right? Very important. Okay, so to approach a question like this, we're going to use the strategy of casework. So we're just going to do different cases and work our way down, work from the largest number possible. But if the largest number has issues, we'll work our way down to find the largest number that follows all of the rules above, which is that there's two E's, that these two E's match up, these two A's match up. So those are some special rules we have here. So first things first, before we go into the cases, there's a very easy observation we should make. And that's that L is equal to 1, right? Very, very important observation, because these are two 4-digit numbers. So the biggest they can be is like 9999 plus 9999, which is like a 19,000 something. So the biggest, that means the largest this can be is like 19,000 blah, 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 right? The largest L can be is 1. So that means straight away we know that L is equal to 1. Okay? Once we know L is equal to 1, all we need to do is work our way to figure out what the other 4 digits have to be. We're trying to maximize the other 4 digits. I'm going to do the first case, which is I'm trying to maximize the next most important digit, which is the thousandth digit, which is E. The biggest E can be is 9, right? So let's do that case. But when we try this case, we run into a little issue, because if we have 19,000 something here, what do these I's have to be? If you add up two 4-digit numbers to get to 19,000 something, I would have to be at least 9, right? I would have to equal 9 to get to 19,000 something. But that's a contradiction, because you can't have E and I both be equal to 9. So when you have E is 9, I would have to be 9, which is a contradiction. Therefore, the case 1 where E is 9 doesn't work. So that's what we're going to do now is move down to a second case where we're going to make E a little bit smaller. We're trying to keep it as big as possible, but 9 didn't work, so we're going to go down one more to 8. So E is 8 now. Now again, something we have to notice is, actually I did that in the previous writing, is that in order for two numbers to add up to 18,000 something, the 1,000th digit would have to be 9, right? Because if you have like 8,000 something, 8,999, 1,999, if you add them together, you're going to get 17,000 something, right? So whenever the biggest 8,000 something can be add up to is 17,000 something. So this would clearly have to be 9,000 something. So I would have to be 9. Now that means when E is 8, it's already guaranteed that I is 9. So we've got a fixed value for 9, I as well. So we only need to figure out the rest of the digits now. So I'm going to focus on the next digit, which is A, right? I'm going to focus on A being the next largest, which is 7. And when A is 7, it would imply that D would also have to be 3, because to get 700 something, you need to add two 300 somethings. And when A is 7, these final digits would also have to be 7. Right? That means our number here is 9387. And if we add 9387 up together, we end up getting this digit at the bottom, 18774. You can do the calculations on your own, but you'll end up getting this answer. There's a clear issue with this though. And the issue is that R7 and A is both 7 as well. 2 digits, 2 letters with the same value breaks the rules we had. Therefore, A can't be 7. Now we go down to A6. And this time we run into a different issue, because what happens is, in order to get 6, this would have to be 3. digit for D would have to be 3 to get a 600 something here. But turns out when we actually add them up, this 86 makes it too big actually, and you end up getting 18,772. So the 6 and 7 don't match on these two numbers. So clearly this is not the answer either. So we go down to A is 5 now, and then here we have our final answer, because it turns out the number we need here to get 500 something here was 2. If you put 9,200 something, actually, let me do it from scratch. I'll show you why the answer is 928. A is 5 works. So when A is 5, right, what happens is we're going to replace these all with 5. So that means the hundredths digit's 5 now, so it's 500 something. So 18,500 blah blah blah. In order to get that, D would have to be 2, right? To get to 500 something, you need to add 200 something together. So let me add 2 here, 9285, right? And if I add 9285 twice, 9285 plus 9285, turns out the answer I get is 18,570. That means R is 7 and N is 0. That's perfect because these are digits we have not seen before, right? There's no 7 anywhere in these other numbers. There's no 0 anywhere in these other numbers as well. So there's no overlapping numbers. So this is a valid answer. And this is the biggest valid answer. That means our final answer is learn is 18,570. So that's it for this cryptarhythm. The key idea I want you to take away is the fact that cryptarhythms are all about casework, right? So first of all, finding the basic things you can find, and then from there on, just doing cases, right? I did first case where A is 9, didn't work out. Then I went to second case, 8. And then within that, I had sub cases even, right? So just don't be afraid to do cases and analyze cases. That's a very, very powerful strategy for problem solving. All right. Hope you guys have a good one. Bye.